then it's going to execute SHM. We have to find out that particular time period. Okay, get into the problem now. I'll take this diagram. It'll be easy for me. Okay, now I think we have a diagram. Will slightly depress the liquid column. So we are not going to move the liquid tube, this tube, this will be fixed. I'm making things clear. The liquid column is slightly pressed and released, so it's going to execute SHM. Okay, what all the displaced liquid? So that particular liquid column will come here, so that okay, we'll show like this. It'll be easier for us. What is this? What amount of liquid that decreased here? That liquid will be available here, no? In fact, it'll be pushed up. So we'll just show it here, no? Try to see the diagram. Very, very important. Now, how much it is being depressed? Okay, vertically. So shall we take this length as some x length got decreased here? So try to notice. I'm going to some x length of column got decreased here. That x length of column will increase here. Here x dash length will increase. This will be x dash. And let this be y. If you can understand this in a very 2-3 steps, we can conclude the problem. Some x length of column, what happen? I'll press it. Then that liquid column should come here. So then this cannot be x dash because this y distance will be same. You will get this alpha because of alpha beta. This should be x dash. This cannot be x. Am I right? If alpha equal to beta, then this would also have been x. Got it now? Okay, first you write some relation between x and x dash in terms of alpha beta so that our ADAC will get over. Sine alpha is equal to y by x sine beta y by x dash. What is the length of this? Total length, let me call delta L. Why that delta L has to be taken is okay. This one. So I just made that green color so that the delta L will become this length of liquid column will become like a restoring force. You can see that the weight of this one, and weight of this one. So this will become like the weight of this particular column open will become a restoring force. excess length of, because see, like a pressure depends on depth, no? So now what happened due to this much of excess length? So it's in equilibrium. Why? Because the pressure at this point equal to pressure at this point. Pressure depends on depth. Now what will happen now? This is the excess length of liquid column. So what is delta L? Excess length of liquid on the right limb. Like this we can write it. So delta L is what? Excess length of liquid in the right limb. So what is delta L? So what is, now shall we, y is equal to, we have replaced. So therefore equating these two, x sine alpha equal to x dash sine beta. So let me replace that. What is x dash? X sine alpha. Now you can ask questions. So what actually you're doing? See, what is the basic idea? It's in equilibrium. When I press this, the liquid will get displaced. So the weight of this excess liquid, the weight of this particular length of column will produce a restoring force, and that will make the liquid to accelerate. Then when you press and release, what happen? It'll be like this. So now this length of this much of liquid column will set up a restoring force, which will make it to accelerate. Then it'll go like this. Like this, the liquid column will be executing SHM. That time period is what we are finding out. Delta L is equal to sine beta So this excess length of liquid column, the right limb, will provide restoring force. This statement is very important. Restoring force to the total liquid column. What is the restoring force? So shall we put it F like this? So what is that F should be equal to? Directly, let me go for it. Area of cross section rho A delta LG sine beta. Why sine beta? Component of weight only should act. No? If the weight of the liquid is mg, delta m, delta mg sine beta is what will be acting. Some of you, what is delta f equal to? Delta mg sine beta. What is delta m? Rho a delta l g sine beta. What is delta l is this particular thing. Let me substitute this one. So this should be equal to ma. What is m? Delta m is different. M is different. M is total mass of liquid. So let's write some terms which are very easy. Total delta m is mass of this part. I'm writing for both, not for green or blue. The total mass is delta m. That force will act on the total liquid column, no? So therefore ma we should write. So this will be rho a, delta l will be sine beta into x g sine beta. So this should become equal to m. What is m? We can write rho total length of the liquid column, no? Now what is the length of liquid column? Rho a h sine alpha rho a gx sine beta get cancelled. So sine beta plus sine alpha. Anybody, can you tell what is that h by sine alpha? What is the length of this part? H by sine alpha. What is the length of this part? H by sine beta. Rho A into length of the liquid column. Initial total length of the liquid column. Total length of the liquid column will be h by sine alpha plus h by sine beta. M, that's why I'm writing M here. Total mass of liquid. That will remain same. So what we can cancel out? Rho A get cancelled. So therefore this acceleration should be equal to Gx sine alpha sine beta. By h, it will be. Okay, very best equation, you can say that one. Huh? Omega square. Okay, this x is missing, no? X, I'll write it here. So the time period will be 2 pi okay, this will become h by g sine alpha sine beta. What is use of this? You can see it is a generalized one. Now you can make it generalized. Now try to notice it. This is what time period of the liquid column, the total liquid column. Not say don't left or right. The total liquid column will be executing SHM. Now, so like every time you can take help of this particular formula. I'll bring the cases. It'll be easy for you, know. If we have let me bring all the cases in this one, what all we studied just now. So if it is like this, I'll fill up a liquid. Some to length h, and it is kept on the ground. I want time period of oscillations of it. So what is alpha beta? Alpha beta will be 90 here. That's all, no? So how come? Because what is alpha beta? Alpha beta will be 90. So this was the advantage of this particular formula now. Every problem you need not to struggle. So alpha beta tends to 90. So what is the time period? Time period will be t equal to 2 pi h by g sine 90 sine 90. So this will become okay. No, a student may think like this, sir, is it applicable? A student as what you will do. Alpha is 90 and beta is theta in this problem. Okay, I agree this one. So means any objective, even in advance also, no. So if you have formula, it's easy. Otherwise, we have to start from the beginning, the way we did. I display the liquid, some length will decrease here. The decrease in length should be increased here. Then the pressure at this point will increase. Then that will be restoring force. So instead, remember formula, where all this formula can be applicable, try to see that one. And not only this, you can see that I'll slightly change. Till now, we took some sort like linear tubes, no? Slightly I'll modify it. If we have a condition like this also. If it is off, so here is what I'm filling up a liquid. No, how to find out the time period of oscillation. Look at the liquid column. It's not some sort of like linear, no, some sort of curved one. The limbs you see, they're not like straight, they're curved. So what has to be done for this? Any method? So what is the basic condition that we see that earlier it was for straight limbs? No, no, we have. So what is suggesting is like, just take help of draw a tangent at the free surface. Where you have to draw tangent only at the free surface. And the tangent what will happen here will make an angle alpha. Similarly, draw a tangent at the draw a tangent to the tube so that it will touch only at free surface. I'll put dot so that there's a tangent. That free surface is very important. Let me. So you draw a tangent such that the tangent should touch at the free surface. The angle made by the tangent that has to be substituted in the time period. I think really this has solved our problem now. Any arbitrary shaped tube also, let's not bother. This will be very difficult for us trying to analyze by any other method. Means just know what we discussed here now. So for that, we should display the slightly this liquid column, and then we should know what is the curvature for this particular limbs. For this, will be one curvature. This will be one curvature. Then we have to solve further. So what he's telling is, what is the method? What is the basic idea for any arbitrary tube? For an arbitrary shaped tube, for an arbitrary shaped tube, draw a what we should draw a tangent alpha beta, right? Alpha beta, what are alpha beta? Alpha and beta are the angles made by the tangents drawn at the tube at the free surface. Okay, this is the free surface. Okay, this I'll write it. This is a free surface. Let me save it. I think it may. Yeah. And now, if you know this formula, any problem of fluids mechanics you can solve. SHM not like that. You should know that one. So I think now students want to okay, sir, thank you very much for good formula. No, I will not need not to bother. You go for this. How you solve this? Can you solve this by that formula? Something totally different, no? Only when liquid filled up in a limbs. Okay, this is going to help us. That's all here. This formula is having own limitation. Then don't think for all fluid SHMs, SHM in fluids, this is applicable only when the liquid is filled up in the limbs. Then this is applicable. See, this is what I think students. That's why I'm scared to give any formula. So once the moment formula they see what happens, students will think that S. For whole chapter we can apply. I don't think so at the level at which we are studying physics is not of that kind where if you know one formula, the whole chapter you can manage. I think such things is not possible here. Only some 5-6 numericals may be related to that particular formula. So in exams, we'll be comfortable if any question comes so that we can, with formula, we can conclude very easily. There's a basic idea of concluding using formula here. Doesn't mean that this formula is everything. Now I'm making clear. Okay, you can work out today rolling SHM, angular SHM, fluids in SHM we have brought it. So tomorrow we'll explore few more. This week, the whole week will be like plenty of like if still we have SHM in thermodynamics, SHM in like a gravitation. So there are so many other things are there which we have to work out here. So try to take the problems which you have some basic idea. With that one, I think so. Plenty of numericals you may come across. Put in WhatsApp and what difficulty you are facing in the question, you can send as a voice message. It'll be easy for us. Like what is the difficulty you are facing in the particular question? So like that, open you can interact with a teacher. Evening, what actually the timings are very like 5 to 6 is our physics time, no? But what actually happens is like either some maths class will be going on or chemistry class will be going on. Very hot days whenever some available, but most of the days what happens that 5 to 6 will be taken by one or the other subject teacher. So that's why I'm finding very difficult to interact with you people.